question. Why are we able to have such precise movement? Let's think about the three main categories of motion: standing, walking, and running. They all use similar muscles. So how do they generate completely different effects? This is where the size principle comes into play. Let's think about it in terms of a boxer being punched. A smaller punch will have less pressure and cause less pain, but a larger punch will lead to a lot of pressure and a lot more pain. The same thing happens in muscle cells. The more pressure that's applied, the stronger the response, meaning more action potentials are fired, leading scientists to the conclusion that the more pressure activates larger and larger cells. A larger cell has a longer diameter, meaning a greater surface area. With more surface area, it will take more stimulation of the presynaptic cell to cause its activation. So the smaller cells, which need less stimulation to reach potential, will fire first. First, a motor neuron fires an action potential. The second step begins when ACK is released by the presynaptic cell, triggering ACK receptors on the presynaptic cell. In the third step, sodium is released into the cell, causing an action potential to propagate into the T-tubes. T-tubes are tubes that run through muscle fibers and allow for synchronous muscle contraction. In the fourth and final step, intracellular calcium is released and actin and myosin are activated, which allows the muscle to move. Through discussing the size principle, we have now learned how pressure changes neuron response, how surface area changes the amount of stimulation needed for an action potential to fire, and how neurons cause muscles to move.